third graders. This week we're going to be digging into one of the polygon families. We're going to be zooming in on the quadrilateral family. So quadrilaterals are special because there are so many different ways to divide them into different groups using their attributes. Remember, attributes are the features or things you can describe about a shape. Once again, just like last week, there's going to be a lot of vocabulary in this video, so you're going to want someplace to take notes along with me while you watch. Go grab your journal and a tool to write with. I'll see you in a minute. All right, so the quadrilaterals. We already learned that quadrilaterals have 4 sides. That's where that quad part is. They also have 4 angles, which is where you measure inside the corner, and they have 4 vertices. Vertices is a fancy math word for corners. The corner points, the outside point. The angle is the inside of the corner, and the vertices are the point on the outside. The quadrilateral family can be divided into 4 groups as well using their attributes. First, let's talk about the parallelograms. Parallelograms are special because they have 2 sets of parallel sides. You can hear it in the name, parallelograms. So parallel means that the lines will never ever touch each other, even if we stretch them out. In this one I've drawn, you can see that this side and this side are parallel. Even if they kept going, they would never touch each other. You can also see that this side and this side are parallel. They would go diagonally, but they would never ever touch each other. Most of the quadrilaterals you've learned about in school fit in the parallelogram family. So we're going to spend some more time talking about parallelograms in just a minute. Trapezoids are special because they only have 1 set of parallel lines. That's why they don't fit in the parallelogram family, because to be a parallelogram you have to have 2 sets of parallel lines. Here's an example of a trapezoid. Now you can see in this shape there's only 1 set of parallel lines. The top and bottom lines could be extended forever and they would never ever touch. But these 2 side lines, well, you can see that eventually they would run into each other right here. To review, parallelograms have 2 sets of parallel sides, but trapezoids only have 1 set of parallel sides. The quadrilateral family has another group of shapes called the kites. Now, when I said that name, you probably pictured the kind of kite you would go fly outside on a windy day. It's shaped something like that. And you're right, the kind of kite you go fly outside is also a kite shape. Now, kites don't have any parallel lines. It's kind of hard to see, but these 2 sides would eventually touch each other. Same with these 2 sides. They would run into each other eventually. So they have no parallel sides. But kites do have 2 lines that are the same length right next to each other. We have 2 short sides that are equal. I'll do a little equal sign in the middle of them. And we have 2 long sides that are equal down here. You might have also seen a weird shaped kite in geometry class. where it's flipped like this. It looks kind of like a dart that you would throw, or an arrow. But it's still a kite because these sides are not parallel. But it has two pairs of equal sides that are touching each other. So to review, a kite has no parallel sides. But it has two equal side pairs that are next to each other. The last group of quadrilaterals don't fit into any of the groups. We're going to call them irregular, because they don't follow any of these regular rules. So this would be where you'd see the quadrilaterals that are just kind of lumpy and crooked and don't fit into any of the other families. Maybe something like this. Kind of like a trapezoid, but it doesn't actually have those parallel sides. See, those two would meet, and those two would eventually touch each other. But also, the sides are not the same length. So in this shape, we have all different side lengths and no pairs of parallel lines. Okay, we've got the four groups in the quadrilateral family: the parallelograms, the trapezoids, the kites, and the irregular quadrilaterals. Okay, that was a lot of quadrilaterals. We're about halfway done, so it's time to get up and move around. You're going to go on another shape hunt in your house, looking for the different types of quadrilaterals we've talked about. If you can, tell someone in your house about the attributes of the quadrilaterals you find and which type they are. I'll see you in a few minutes. Now we're going to zoom in on the parallelogram family, because like I mentioned before, they get a little complicated. Remember, parallelograms have two pairs of parallel lines, lines that will never touch each other even if you extend them out forever. And that's true of every shape we're going to talk about in the parallelogram family. They will all have two pairs of parallel lines. Some special parallelograms we're going to talk about are rectangles, squares, and rhombuses. Now, before we go on, let's prove that rectangles, squares, and rhombuses are all parallelograms. We have two parallel sides there, and two parallel sides here and here. Here in the square, same deal. Two parallel sides there and there, and two parallel sides on the top and bottom. And finally the rhombuses. These sides are parallel, and these sides are too. So we can sort the parallelograms by either looking at how long the sides are or by looking and measuring their angles. If you sort parallelograms by measuring their angles, the way to do it is to look if they have right angles or not. Remember, right angles are those perfect square L-shaped corners. Now, taking a look at our shapes, rectangles have all L-shaped corners. I'll draw little squares to help us remember that. Squares also have L-shaped corners on every single corner. but rhombuses don't. Some of them are acute, they're little small angles. Some of them are obtuse, the big wide angles. But there are no square corners in there, no L-shaped right angles. If you looked at the length of the sides, you could group the parallelograms by which ones have all equal sides and which ones don't. In the rectangle, obviously it does not have all equal sides. It's got short sides and long sides. But on the square, you know that squares have all equal sides. That's part of what makes them a square. This side is equal to this side, which is equal to this side, which is equal to this side. They're all equal. Rhombuses are actually the same. This side is equal to this side, but if we measure, these sides are the same lengths too, they're just tipped diagonally. It's like you took the square and squished it. Have you noticed which shape is in both the equal sides group and the right angle group? You're right, it's the square. Using what we just learned, we can group all of those parallelograms into special families. Over here, we have the rectangle family, where we put the shapes with 4 right angles. All rectangles have 4 right angles, like that one. And like the square. Technically, a square is a special type of rectangle. Over here, we have the rhombus family. In the rhombus family, you don't always have 4 right angles, though sometimes you do, but you do have all equal sides. So we have the rectangle family, where there are 4 right angles, and the rhombus family, where all the sides are equal. Do you see how these two are overlapping? That's because the square family fits into both groups. A square is a rectangle because it has 4 right angles. A square is a rhombus because it has all equal sides. A square is a parallelogram because all its sides are parallel. And a square is a quadrilateral because it has 4 sides. So squares are definitely VIP, very important polygons. Okay, I hope you got all of that copied down in your notes because you're going to need it to do your homework pages. For the first page, we're going to look at 191. At the top, it has a bunch of shapes and a bunch of directions for how you should color or mark the shapes. You're going to identify the attributes of the quadrilaterals below and follow these instructions. It's going to ask you to do things like draw a blue loop around each shape with 2 pairs of parallel sides. So it's asking you to find the parallelograms. There's a bunch of other directions like draw an X above each shape that has 4 sides that are exactly the same length. So you're drawing an X above the rhombuses. Down here, there's some multiplication facts to practice. Then you're going to turn the page to 192. On this page, it's asking you to cross out the figure that's not a parallelogram, or find the figure that's not a trapezoid. Down here, it wants you to use what you know to compare some shapes. How is a trapezoid similar to a parallelogram? Use sketches and words to explain. But also, for number 4, how is a trapezoid different than a parallelogram? Again, use words and sketches to explain. At the very bottom of the page, there is some adding and subtracting review. All right, that's all for now. Good luck with all your shapes this week.